So welcome, here is our chapter review. Let's begin with this problem. We're asked, based on the graph shown, let me zoom out a bit, to identify the coordinates for points A and B. Now with every problem in this review, remember the goal is to test how much you understand. I, of course, am going to write out the solutions, I'm going to explain things step by step, but if you just watch me do this and you don't do any of the work on your own, you're not going to benefit as fully as if you work through the problems. So that's why I encourage you, please pause every problem when it comes up. I'm going to try to remind you to pause, but I might not say it every time. So pause when a new problem comes up before I start writing anything. Try it on your own with your personal formula sheet at hand, and then unpause to check your work. If you got the problem wrong, then go back in our notes to similar problems. You know that's something you need to review. Make a note of that. So I really encourage you, please actively engage as you work through these problems. So let's pause for a second and give everybody a chance to work at this. If you could find the coordinates for point A and point B. Now we know we always write coordinates in x, y form. If you forget it, the order actually aligns with the alphabetical order. X comes before y. So the x coordinate is the horizontal distance from the origin. The y coordinate is the vertical distance. And when it comes to positive and negative, for horizontal, positive is to the right of the origin. The origin is this cross point. And negative is to the left. For the y values, up is positive and down is negative. So I'm going over 1, 2, 3, -4 horizontally for point A. And then I'm going up 1, 2, 3. So it's the point -4, 3. For part B, it's over 1, 2 in the positive x direction and down 3 in the y direction. So point B will be that. Take a moment to graph this, unpause to check your work. Now when it comes to graphing straight lines, we know one approach is to find the x and y intercept, and that will always work. But whenever it happens to be of the form y equals mx plus b, then the faster approach is to identify the slope, which is the value being multiplied by the x. In this case, it's -2. Realize that that always represents the rise over the run. And you can turn any number into a fraction by dividing it by 1. The y-intercept is the number that's being added to the x term. So in this case, it's a +3. So then when I'm graphing it, you graph the y-intercept first. You go up 3. It hits the y-axis here. And then to find the next point, you use the slope. It says you rise, you go down by 2 to go over by 1. Gets us this next point here. And that's how I'd graph this equation. When it comes to this, especially since our class is online, if it was a paper, you could just write out your answer like this. But on online, likely what will happen in problems like this is you'll be given multiple different answers that are already graphed for you, and you have to select the correct one. I really encourage you on your blank scratch paper, actually do the problem without looking at the answer choices. Get your answer correct, and then you select which one matches your answer. There's probably going to be slight differences between the different answer choices, and if you're just looking, you might mistakenly pick the wrong one. However, if you've got your answer choice already written down, then you can see and check all the details to see which one actually matches your work. Okay, why don't we attempt these next two problems? Remember to pause, try this one, and then unpause to check your work. So when reading this function notation, we know to look at what the input is. And remember, the input is what's inside the parentheses. That is what your x has become. So everywhere there's an x in the equation, I need to replace that with a -2. And whenever your input is negative, I really encourage you to keep the input in parentheses as you substitute it in the equation to make sure everything gets distributed or exponents get dealt with correctly. Now, -2 squared, if you do in your calculator parentheses -2 close parentheses square or -2 times -2, you'll get the correct answer of 4. If you got -4, then you've typed it into your calculator wrong. 3 times -2 is -6 minus 5. So I'll get a 4 plus -6 is a -2. minus 5, and we should get negative 7 as our answer there. Here, my x value, what's inside the parentheses, is 2. Substituting it into the equation, 8 minus 3 times 2, 8 minus 6, and we'll get the answer 2 is our answer. Use the vertical line test to select which of these graphs are functions. So let's pause and look at each of these graphs. Identify which ones are functions using the vertical line test. Unpause to check your work. Now I'll zoom in on these one at a time. The way the vertical line test works is it says imagine that you could draw vertical lines through the graph at all the different points. If it ever hits the graph in more than one location per vertical line, it's not a function. So here as I draw my imaginary vertical lines, if you need to, you can trace your finger over the screen. We see that it only hits one point at a time. So that means this one is a function. Let's go over to B. Here as I trace my imaginary vertical lines, it only ever intersects one point, so it is a function. Down to D. Again, no matter where I trace, it only hits one point. This is a function. And the last one of the provided answer choices, here if I draw many different lines, I see I hit in two places. See, we're hitting here and also here, or here and also here. This one is not a function because it doesn't pass the vertical line test. Now just to get a bit more practice, consider this equation, the one drawn by this blue line here. Use the vertical line test and determine if this is a function. Well, the only vertical line I could draw through it matches itself, but do you see it's hitting many, many points on the line? In fact, infinitely many points on the line. This is not a function because it intersects in more than one location. So here I added this problem. Let's add one more. Use the vertical line test to see if the blue line is a function. Whatever vertical line I draw, it only intersects one point, so this one is a function. So here we are asked to find the x and y intercept for this equation. And a helpful reminder when you're finding the x or y intercept is you let the other variable be 0. So if we're going to find the x-intercept first, then I let y be equal to 0. So for the x-intercept in the equation, I replace y with a 0 and solve. So 8x. Now negative 2 times 0 is 0. So I could write minus 0, but when you subtract 0, nothing happens, so I could just leave that there. 16, let's divide both sides by 8 because, of course, 8 written next to x is implied multiplication. To undo it, we'll divide. And we get x is 2. So the x-intercept happens at x equals 2. To find the y-intercept, you let x be 0. So 8 times 0 minus 2y equals 16. 8 times 0 is 0. Minus 2y equals 16. Now at this point we need to be careful how we rewrite the next line. While the 0 can go away, the subtraction symbol cannot because it's actually making this whole minus 2y term negative. So I need to rewrite it as minus 2y equals 16. I wrote the multiplication dot to remind me these are being multiplied. I'm going to divide both sides by negative 2. And I get y is equal to negative 8. Now, to find the x and y intercept, you've got a particular pattern. And ask yourself after you did this problem, do you know the pattern? Do you have it memorized? If not, write it down in a clear way on your personal formula sheet. To find the x-intercept, you set y equal to 0 in the equation and solve for x. To find the y-intercept, you set x equal to 0 and solve for y. So make sure you have something like that written where you can understand it. So next up, let's use the x and y-intercept to graph an equation. So I need to find them first. Again, remember, you should pause this video, complete it all on your own, and then unpause to check your work. To find the x-intercept, we set y equal to 0, so 3x plus 5 times 0 equals 15. 3x equals 15. Divide both sides by 3. And we'll get x equals 5 as the x-intercept. To find the y-intercept, make x 0. So I get 5y equals 15. Divide both sides by 5. Y equals 3. And then when it comes to graphing, you just have to plot these 2 points and draw a line connecting it. So the x-intercept at y equals 3. So the y-intercept happens at y equals 3. The x-intercept happens at x equals 5. Each of these tick marks represents 1 unit. And then the line is drawn that connects these. Next, we're asked to find the slope of the line. And I could do that by graphing these points and then calculating the rise over run from the graph. Or I could use the formula that we discussed in earlier notes, y2 minus y1 divided by x2 minus x1. I need to keep in mind x1, y1, x2, y2. It can be helpful to write that above to make sure we don't mix things up. So 8 minus 0 over 0 minus negative 2. Now 8 minus 0 is 8, minus a negative actually becomes a positive. So that becomes divided by 2, so the slope is 4. So here I'd encourage you pause the video, unpause to check your work. We're asked to identify the slopes, and just in terms of the general value, we're not going to calculate the actual value for some of them. This is an upward straight line, so it has a positive slope. This one is a flat straight line, so it has 0 slope. Think of slope as the measure of steepness. Downward, so it has a negative slope, it's downhill. This is a straight upwards one, it's like infinitely steep, so we say that's an undefined slope. So here we're asked to graph this function. I'd encourage you, pause the video, try this on your own, unpause to check your work. Now I notice this is nicely set up in the mx plus b format. Be on the lookout for that. So I can note off to the side the slope is 5/3 and it's already in the rise over run format. Make sure you memorize slope as rise over run. It would be a mistake if you mix it up and say run over rise. The y-intercept, or the b value, is -2. Notice I do need to include the -2 because we're subtracting 2. It's what's being in addition to the term that involves the x, so all of it is the -2 here. So then I would graph it. I'd go down 2 for my y-intercept, graph the y-intercept first. It gives you a starting point that you can then use the slope to find the next point. So I'm going to go up 5, so go up 1, 2, up 3, up 4, up 5. So I'm going to go up 5 from there. I'm just using this to help show up 1, up 2, up 3, up 4, up 5. And then it says you run over 3. So I'm going to run over 1, 2, 3. And I'll get to the point 3, 3 here as my next point. Now what was shown here in blue was just helping me count, giving a visual cue for what's going on. Let's just double check our slope. We went up 1, 2, 3, 4, 5. Be sure to count this origin as a point because this is at 0. So we went from -2 up to 1, up to 0, up to 1, up to 2, up to 3. That's up 5. And then we went over 1, 2, 3. Connect these with the straight line. And we've graphed this. Now here we're asked to convert this straight line equation into slope-intercept form. Slope-intercept form is y equals mx plus b. Be sure to pause if you haven't. Try this on your own. And here we're going to use algebra. The whole thing about slope-intercept form is we want y to be by itself on one side. I'm going to find y. It's here. It's not by itself. To get it by itself, I need to move the things that are on its side. I've got a 2x on its side, so I move it by doing the opposite. I'm going to subtract 2x from both sides. Now the 2x minus 2x goes away on this side, and we're just left with y. 10 minus 2x, well, you can't combine just a strict number and then number times a variable. So all we can do is write 10 minus 2x. And that is this equation converted to slope-intercept form. Now here we're asked to match these four graphs with the equations x equals 3, x equals negative 3, y equals 3, y equals positive 3. Take a moment, pause the video, match each equation with each graph, and then unpause to check your work. Now keep in mind, any an x equals equation will be a vertical line because vertical lines are the ones that cross through the x-axis. Any y equals, strictly a number, not a number in variables, will be a horizontal line because they're what crosses through the y-axis. So x equals 3 matches up with A because it hits the x-axis at the point 3. X equals negative 3 matches up with the graph shown in C. Y equals negative 3 is our B because it goes through the y value of negative 3. And y equals 3 is our graph in D. So here we have a word problem. It says the function f of x estimates the value of quantity f, x years after 1980. I need to pay attention to this unit. So x is not the year itself, but it's the number of years since 1980. Here's my function. It says project the value in 2023. The first step is to turn this into an x value. So 2023 minus 1980, that will tell me how many years it's been since 1980. And if we type that into our calculator just to double check, we don't want to make a mistake from a small calculation error, that is 43 years. Now I use that as my x value into this equation. F evaluated at 43 is 0.35 times 43 plus 15.3. Again, let's bring up our calculator. And I'll get 0.35 times 43 plus 15.3. And we get 30.35 as our answer. So for problems like this, just really pay attention to the units. The key idea is that the units were years since 1980. So this 2023 value had to first be subtracted from 1980 to get our value of x, 43. That was then substituted into our equation to find our function value at 43. So here we have two problems. Please pause the video, try these, unpause to check your work. To tell if something's a ordered pair is a solution to the system of equation, remember that we have the x and y values given to us that we're plugging in. The ordered pair is an x-y pair. So I can substitute everywhere there's an x, I'm going to substitute 1. And everywhere there's a y, I'm going to substitute 2 in both equations. Let's rewrite that. 4 times 1 plus 2. We're going to see if that's equal to 6, and I'm going to write out the second one as well at the same time. 1 plus 2 equals 3. Now let's check. 4 times 1 is 4, plus 2 would give me 6, which is indeed 6. The first one checks out. 1 plus 2 is 3, which does equal 3. When you substitute 1, 2 into both equations, you get true values, so it is a solution. Let me be specific. 1, 2 is a solution to this system. Now let's check the next one. Similarly, 1 gets plugged in for each x value in the two equations. 2 gets plugged into each y value, and then we test, is the result what we expect based on the equations given here. So 4 times 1 plus 2 is supposed to equal 6. Let's check. 4 times 1 is 4, plus 2, it indeed does equal 6. The first equation works out. 2 times 1 plus 2 times 2 is supposed to equal 8 by the equation. 2 times 1 is 2, plus 2 times 2 is 4. Now here's where we get a problem. 2 plus 4 is actually 6, but it was supposed to equal 8. So this one is not a solution. Unless it makes both equations true, it's not a solution. If even one fails, it's not a solution. So here we're asked to determine what the solution is to the system of equations, and we've got two main methods we use, elimination and substitution. And based on how the problem's written, we might prefer one to the other. So here, I think this could be a good choice of substitution, because for the first equation, x plus y equals 10, I could quickly get y by itself by subtracting x from both sides. Y equals 10 minus x. Now this y value gets substituted into the other equation. Remember, you always substitute the isolated equation into the other one that you haven't manipulated. So we have 2x plus 3 times all of y. I'm going to put all this in parentheses to make sure I distribute it correctly. Those small steps, like putting the substituted equation in parentheses, will really help if you stay consistent, not make small mistakes. Equals 26, because now I know this multiplied by 3 has to be distributed to both terms. 3 times 10 is 30. 3 times a negative x is a negative 3x. Now before I start using algebra, let's clean up this side. For instance, 2x minus 3x can combine to give me a negative x. Plus 30 equals 26. Let's get x by itself. I don't really like dealing with this negative x, so I'm actually going to add x to both sides. Adding x to a negative x gets rid of it, and I get 30 equals 26 plus x. X is still not by itself, but at least it's positive. Now I can subtract 26 from both sides. The 26 on the side with the x cancels. 30 minus 26 is 4. So the x value is 4. With the substitution method, most of your time will be spent getting the first variable. Once you have the first variable, then that goes into the equation that you isolated for. So I take this x value of 4 and I substitute it right in here. So we get y is 10 minus 4, and we get y is 6. So the solution is 4, 6, the ordered pair. Now in this problem it says find the solution using the substitution method. Again, if you want to use elimination, you could, but in this problem I'm just giving you a hint that the substitution would be faster based on this problem. So don't feel like you have to use the substitution method. If you know how to use the elimination method, you can, but we have been given a hint that the substitution method would be more efficient here, particularly because I see I've already got y solved for, so I'm going to substitute that into the other equation. And remember to put it in parentheses, so x plus the substituted value of y, 4 plus 3x equals 8, substitute in the other equation. And we get x plus 4. There's nothing, this parentheses, nothing needs to be done because there's no multiplier, so I can just drop it. I'm going to combine like terms. X plus 3x will give me 4x plus 4 equals 8. Let's solve for x. I'm going to subtract both sides by 4, move what's farther away first. 4x equals 4. Now this 4 that's by the x is implied multiplication, so to get rid of it you divide. X equals 1. Now you get x equals 1, that's only part of this work. We then need to take that value of 1 and substitute it back in the equation, and we get y equals 4 plus 3 times 1. This will give us what the corresponding y value is. And we get y is 7. So the point is 1, 7. Next, we solve the system of equation, and we're given a hint to use the elimination method. And when we look at our system, we see why. Remember, the elimination method says add the equations together, and if one of the variable cancels, then that's the exact right approach. When I add x and negative x, the x's cancel, and I'm left with 3y, because y plus 2y is 3y. 9 plus 15 is 24. Implied multiplication there, so we divide by 3. Y should be 8. Now you take that y value of 8 and you can plug it into whichever the two equations seems easier to work with. I'm going to go with the top one. And we can subtract both sides by 8. And we get x equals 1. So let's combine that to a coordinate pair. The solution occurs at 1, 8. So previously we've seen some systems of equations that had one unique solution, but we know from our earlier notes that there's basically 3 categories. You're either going to have one solution, no solution, or infinitely many solution. I encourage you to pause the video and attempt these 2 problems on your own. Unpause and check your work. You're basically, through solving the system of equations, identifying if there's one unique solution, no solution, or infinitely many. And if you need a review of that, in one of our earlier sections of notes, we went through this in detail. So let me zoom into this one. As I begin to solve this, let's see. It's not a great candidate for substitution. It is a good candidate for elimination. However, to this point in our notes video, I've only done elimination problems where there was no extra step needed. You could just immediately add and something would cancel. That does work. However, the elimination technique could actually be extended to more types of problems that are a bit more complicated, where you do something to one equation and then add, and it will still work. Let me show you an example of this now. So think of it as we're adding to the idea of the elimination method. It's just our previous problems were one-step elimination problems. This is a two-step elimination problem. Do you see how the x terms are opposite? There's a 3x and a negative 6x. If we could multiply, and let me change the color, the top equation by 2, and what's done to one side must be done to the other side, that would turn this into 2 times 3x is a 6x, 2 times 4y is a positive 8y, and then 2 times 9 is 18. Now if you do this multi-step elimination method, you must remember what's done to one side must be done to the other. And now if we consider adding this manipulated first and second equation, negative 6x plus 6x, the 6x's completely cancel. But it also happens that the y's cancel because it's a negative 8y and an 8y, so there's nothing left on the left side. How do we write nothing? We write it as 0 equals 10 plus 18 is 28. Is this true? 0 equals 28? This is not true. This is false. 0 is not equal to 28. So if when solving the system of equations you get a very false answer, you know the answer is that there's no solution. Now this problem was a bit more complicated than usual because it was a two-step elimination, and this I believe is the first time we've seen it in our class notes. But keep in mind, if the problem's not immediately set up for elimination, if you could multiply one equation on both sides by a value, and then that new equation could be added to the other term where a variable disappears, that works as well. Now for the next one, determine if it has one solution, no solution, or infinitely many. This is set up very nicely for substitution because the y equation is solved for, so I can substitute that into the other one. 2 times, I'm going to keep this whole term in parentheses to make sure I distribute. Okay. 2 times 4x is 8x. 2 times 3 is a plus 6. And now let's get the x's to one side. I'm going to subtract 8x from both sides. What happens when you subtract 8x from this side is it goes away, but it also goes away here, right? 8x minus 8x is 0. So I'm end up with 6 equals 6. 6 equals 6 is a true statement, and it does not involve an x. If when solving you get down to a numerically true statement, 6 equals 6, that's when you know you have infinitely many solutions, because it turns out that the two lines, although they might not have looked the same, they are the same line, just written in a different appearing format. So here we're asked if the inequality would use a dotted or solid line. Remember, dotted or dashed lines are for these inequalities. Solid lines are used by the ones that have the or equal to line. So seeing here, this is clearly just this one, so it is a dotted line. Whereas this one has the or equal to line, and that's why we would use a solid line for this one. Now we're asked to graph the inequality. The first step in identifying if we're graphing the inequality, I like to just look and make a note off to the side. This is a or equal to, so I'll use a solid line. It does involve just an x and a number. So we know that x graphs, those cross through the x-axis, they're vertical lines. They separate the coordinate plane into left and right of the line. So we know when this is a x is less than or equal to 2, so if I was to graph that, I'd have at x equals 2, I have a solid line through it, and now this solid line separates my coordinate plane into the values before to the left, values after to the right. Now if we're less than, x is less than, does that sound like we're before values less than 2, or values to the right greater than 2? We're values less than 2 to the left. So when it's just an x line, we talk about left and right instead of up and down, because it doesn't make sense to talk about up and down for a vertical line, but we shade to the left. Whereas for inequality involving strictly y, or y less than or equal to some term of x plus or minus a number, that's when we can talk about up or down in terms of the greater than or less than, and that was talked about at length whenever we covered these sections earlier in our notes. So I'm going to immediately note, because there's no or equal to, this should be a dotted line. And because it's a y greater than, I need a shade above. After that, I basically think, how would I graph the line y equals 4, and then make these modifications to it. To graph the line y equals 4, I go up 4, and y equals a number is a horizontal line. However, I need to be careful. It should be a dotted line. And then that splits the coordinate plane into the values above, the values below. If y is greater than 4, I should be shading above. Next up, we're asked to graph this inequality. So again, pause this video, try it on your own, unpause to check your work. I'm going to make a few notes. There's no or equal to, so I should use a dotted line. It is y is greater than, so that means I should shade above. Okay, those are the two things I can take from the inequality. Now if I was just graphing y equals 4x minus 5, that's a straight line with a slope of 4. So my rise over run could be written as 4 over 1. Putting the over 1 helps me see this as a fraction. The y-intercept, b, is negative 5. So I'm going to go down, y value of negative 5. It hits the y-axis at negative 5. And then my rise is it goes up 1, 2, 3, 4 to run over 1. So we get this as our next point. It's going to be a dotted line through those points. I think I got a little off. Connecting those 2 points. And I've got 2 sections. The section's greater than the line or less than the line. Y is greater than, so I should shade above the line. Next up, we're asked to graph these inequalities. I'm going to write my coordinate axis here. Now for the first one, I'm going to write it in blue. I see that it's a dotted line because there's no or equal to. And because it's a y greater than, that means I should shade above. Okay. The line itself, it has an x-intercept at 2, right, because it's a plus 2. If I wanted to imagine it as x plus 2, I see the slope is the number in front of the x. When there's no number written, it's an implied 1. So that's a 1 over 1. The y-intercept is at 2. So I hit the y-axis at 2. I go up 1 over 1 to get my next point. I'm going to draw that with my blue line. It should be dotted because it's not or equal to. And I know I shade above because it's a greater than. Now remember, the point of this review is to give us a few more problems to just check our work. If you're unsure of anything that I'm saying, the review goes through things faster. Go back to our actual lesson notes and we really go through multiple problems in detail at a slower speed. So go back to the lesson videos if you have any questions about this content. For the second equation, I notice there's again no or equal to, so it's a dotted line for this second one too. But since its y is less than, I know I need a shade above. Below. Gotta watch what I'm saying. If I looked at the equation negative x plus 4, that's an implied negative 1 multiplied by the x if it's just a minus x written. So my slope is a negative 1, or I could write that as a negative 1 over 1 to see my rise over run. The y-intercept is at 4. So up at 4, I have my y-intercept for the second graph, and it goes down 1 over 1, hits this point. Down 1 over 1 hits the next point. So let's draw that dotted line. But for this one, it said you should shade below, right? So I shade the whole section below. And for systems of inequalities, the overall solution is the overlap. So this overlap section that we see here, I'm going to try to highlight it here. This whole overlap section, not including the lines themselves, is our solution because it's where it's shaded for both inequalities. And for this problem, if you have a pencil, that will really help in seeing the difference in shading, or you can kind of go through it in your mind's eye and think, okay, for the blue equation, I shaded everything above. For the red equation, I shaded everything below. Where do they intersect? Only in this section. So this is a problem where we're kind of giving the reverse idea. We're given the graph. It says, consider the system of equations already graphed for you. Select the system of equations that represents the graph. So you're given the graph and you're asked to decide from this multiple choice what's actually the correct answer. Now, based on which one is shaded more strongly, can y'all agree with me that this quadrant over here that I'm kind of shading again in purple, this is our overall solution? Because if you looked at the original, while there was some shading here and some shading here, this was the darker shading indicating the overlap. So this is my solution. I see that this line has a y-intercept at 2. This one has a y-intercept at 3. So if I was going to work out this problem, I'm not going to focus on the answer choices yet. I'm going to try to write out my own work. I know that I've got, let's say this is line 1, this is line 2. For line 1, it's got a plus 3, and do you see that we're shading above this line based on what you can see here, and it continues through here? We're shading above. To shade above, you have to be y greater than. And because it's a solid line, it should be greater than or equal to. Y is greater than or equal to something plus 3. I'm just gathering the specific information that I can see directly from the graph without too much detail. Now to find the next point, the slope is it goes down 1 over 1 to get the next point. So the slope is a negative 1 over 1x, or this could be written as y is greater than or equal to negative x plus 3. To get the next point, what do? Well, it's at the line 2. Y-intercept is at 2. And do you see we're shading below? So I found the y-intercept is at plus 2, just visually seeing it. I noticed that the whole inequality shades below this line. And do y'all see that it's a dotted line? It's not a solid line. So we should have y is less than something. Now let's find the slope. I'm going to erase some of this so we can see that more clearly. So the slope starts here at the y-intercept of 2, and do we see it goes up 1 and then over 1? So that's a rise of 1 over 1 x. That would give me the inequality y is less than x plus 2. And I'm going to look to see which one of these matches that. A doesn't work because they're both less than. B doesn't work because it's got the inequality switched around. Or actually, I think it does. Let's see. This is where we need to be careful. My answer actually matches B. It just doesn't initially look like it. Do you see it has, my line 2 is written as the first one here, but it's the exact same inequality, y is less than x plus 2. The second inequality is also matched here. It's just these two have their order switched around, which is okay. 3 minus negative x. The key details have remained the same. So answer choice B is the right one. Let's just talk about the wrong answer choices, though, and how you might eliminate some options. So what I did is I actually just solved the problem from the start and then said which of the answer choices match. But here's some key takeaways that you could use to eliminate some answer choices, because it's always helpful to reduce the number of options you're looking at. Do y'all see that one line is dotted and one line is solid? So any inequality doesn't have at least or exactly one inequality with a or equal to is out. So A is out because they would have both been dotted. Same thing with C. These don't have a or equal to, so they're both dotted. So C is out, no matter what else it contains. Only B and D have one with the or equal to and one without, which would create one solid, one dotted. So in deciding between B and D, it looks like it's the actual exact same inequalities. I have our equation x plus 2x plus 2. And I have a 3 minus x, 3 minus x. The difference comes from this has a less than, where this is a greater than. So let's look at the line, x plus 2, the line that hits the y-intercept at 2. Are you shading above or below? From this section, we can see that we were shading below this line, which is why this one is not correct, because this would have you shade above, but we were actually supposed to shade correctly below this line. This greater than or equal to would have this one shaded above, whereas this one would be shaded below. And we see that's the exact opposite of what you see in the graph. So this kind of problem's a little bit trickier, but focus on key things that you can see from the graph, and then process of elimination, you can eliminate some options, and then focus your mind on what the remaining details tell you about which of the inequalities actually is representative of the graph shown. So that's the end of our review video. If you have any questions, please contact me through our campus communication, and I'll be very happy to help. Bye.